Hello all, welcome back to my channel once again. So in this video I'll talk about the competence number 1, task number 6, about the speed governor that every ETO cadet has to accomplish, the task that is assigned by the DG in the TAR book, to get to know about the speed governor and get it attested by your senior management staff on board. So generally, I thought of covering this topic just because many of us have a doubt how to approach the senior officer, how to get, we just have a small, kind of insecurity or inferior, I don't know how to put that word, but yeah, will not feel free to ask or clear that out. So I just wanted to get to know, guys, that okay, don't worry, I'm here to help you out. Well, speed governor, let's get into the content. I don't want to talk much. I'll get into the content about the speed governor. As the name suggests, governor, as the English name says, it's a governor. It is governing something. Here the speed governor is governing the speed of the main engine. It governs, in addition, it also controls and maintains the speed of the engine. Okay, so why it has to govern and control or maintain the speed of the engine? Because the speed will not be constant. It will vary. Since you're a cadet on board, maybe you would have experiences rolling, pitching. Maybe you have seen when a ship is fully loaded, how much it is, the weight of the ship varies. When it is half loaded, how the weight of the ship varies. You have seen it. So all these factors contributes to the variation in speed of the engine. So in order to evade this variation and to maintain a constant speed, we are using something called governor on board to maintain the speed of the engine, and also to control by setting a desired value at what speed we wanted the ship to go ahead with. So all right, so this is all about the governor. And in this governor there are two types of governor. One is mechanical, the second one is hydraulic, the third one is electronic. So basically there are 3 types of governor. So in the mechanical and hydraulic, it is the same. For the picture, to get an idea, you can Google it, but I'll make it very simple so that upon seeing this video, then you can go ahead to watch some pictures in the Google so that it'll be clear for you. So basically in mechanical and hydraulic type, it's almost the same construction with the 2 fly weights. The 2 fly weights will be controlling the fuel rack. Fuel rack is something that controls the engine speed by injecting the amount of fuel. Okay, so basically in the mechanical and hydraulic type governor, there is something called fly weight that is connected to the fuel rack, which in turn controls the speed of the engine by injecting the amount of fuel. More the fuel, higher the speed of the engine. Less the fuel, less is the speed of the engine. The only difference is in a mechanical type, the 2 fly weights are connected to the fuel rack. Okay, the second hydraulic type, the fly weights, same, again connected to the fuel rack, but this time it is through a control valve. Any hydraulic system will be having valves, right? So fly weights again connected to the fuel rack, but only thing is in between you're going to have a control valve or a pilot valve. Okay, if that pilot valve is in between, obviously any valve would be operated with a fluid, a hydraulic fluid. So this time in the hydraulic type governor, you're going to have a fluid, a hydraulic fluid, which creates a pressure on the valve, opening and closing on the valve, which in turn is going to activate or move the fuel rack proportionate to the valves, movement, valves pressure. So basically got it. I hope you got it. So mechanical and hydraulic type, fly weights connected to the fuel rack. Only in the hydraulic, it is the control valve with hydraulic fluid in between. So this actually operates the governor, okay, in between what is flyweight, weight, how it is working, okay. This is the construction. Flyweight weight is something that is actually rotated by a centrifugal force, by the action of the main engine's crankshaft. So if I'm going to say all those words, it will be confusing for you. You don't get into it. So you know what is governor and types of governor, how a governor actually operates. Governor is mainly operated with the help of that flyweight weight that is controlling the fuel track, okay. Just have this idea in both. And hydraulic, you know, there is a pilot valve, control valve using a hydraulic fluid that is operating. Simple. Now the third one is electronic type governor. Electronic type governor is the real one for ETOs, you know, because here we have the sensors, communications, comparators, amplifiers. So in an electronic type governor, what happens is, if you go to the aft of the engine, you will see a flywheel, right? Flywheel, where you can see the shaft coming out of the engine. So on the sides of the flywheel, if you can notice, you can see the pickup sensors, the speed measuring sensors. So one such speed measuring sensor will measure the speed and sends a signal to an amplifier box, and inside that amplifier box you are going to have a comparator. Here it is same, okay, I'll talk about later. So the speed measuring signal, the measured speed signal, is sent to the amplifier box where it has a comparator. There inside this box, the measured speed is compared with the set speed. Suppose we have set the engine at 78 rpm and the measured signal is 76. Now it is going to, the measured signal is sent to a comparator amplifier box, and it is compared with the set value of the engine. And the set value minus measured value is the offset value. And based on this offset value, a proportionate signal will be sent to control the fuel lever actuator, which in turn injects the amount of fuel so that the engine speed varies. Simple. So this is all about electronic type governor. So basically in electronic, I'll repeat, the proximity sensor senses the speed and it is compared in the comparator box, and based on the offset value, a proportionate signal is sent to the fuel lever actuator where the amount of fuel is injected proportionately. I told about offset. The main thing is offset value. What is offset value? The measured value, the set value minus the measured value. So this is the offset value and the signal is sent. So this is all about this. And more, other than this, in a governor, they talk about droop setting, they talk about hunting, they talk about deadband. Hunting means it is the fluctuation, the speed. Deadband is something when the governor comes into action for a corrective adjustment, let it be. But the droop is the main thing. In the droop, what I would say is, we as the ETO cadets and officers have to know the droop is very important. When a generator is running from no load to full load, the speed will drop. You know, the rated speed in almost all the generators are 720 rpm, but when the load of the generator increases, the speed will tend to decrease, you know. So we are limiting up to how much rpm engine speed can be reduced, okay. So this limitation and this setting is called the droop setting, and this comes into play mainly when two generators are running in parallel. For example, if the droop setting is 5%, means we are allowing the engine to come below 5% of the rated speed, but not below that, okay. So we are limiting it. Okay, if the load increases, we can come below up to 5%, but not below that. So this is how we are limiting it. So in a droop setting, what we are doing is, we have to set these two generators that are running in parallel at an equal droop setting. Suppose if number one generator, number two generator, this is number one, this is number two, these generators have to have an equal droop setting. For example, if this number one is having 10% of the droop setting, and if number two is having 5% of droop setting, now what happens is, when generators are running and taking on load, this number one generator with 10% droop setting will come up to 10% below of its rated speed. This number two generator with 5% of droop setting will come below 5% of the rated speed, okay. So the generator with the lowest speed, for example, number 1 with the 10% will take only less load, whereas the number 2 generator with 5% that runs only below the 5% of rated speed will take more load than number 1, because this is running at low speed, so it will take only less load. This is running comparatively more speed, so it will take more load. So unequal load sharing will be taking place, and we don't want that. So it is always good to ensure that we are running both of them at the same RPM, at the same droop setting. So there is even a formula like no load minus full load divided by no load, but those are all okay. For an ETO as a cadet, you know what is governor, you know types of governor, and you know what is droop setting. Perfect, this is enough. And in MA engine, it's almost like electronic governor. We don't have any mechanical or electronic governors. It's totally with the with the sensors, amplifiers, a timely fuel injection. Okay, so I hope I helped you a bit. So yeah, I'll come up with more other tasks that is mentioned in the TAR book. Thank you, all the best.